Hello, hello. Now am I audible? Now am I audible? Hello, 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 hello. Okay, so let me continue with our session. So, organic compounds. Actually, to organic compounds, we can classify into two types: acyclic or open chain compounds, and cyclic or closed chain or ring compounds. So, acyclic compounds or open chain compounds are the compounds where you have only straight chain present of carbon atoms. No way they are forming any closed structure. Either they are arranged in straight chain or branch or any way, but there is no any cycle formation. Like you have cycle formation in case of cyclopropane. So no any this kind of cycle formation is there in this class of compound, which is acyclic or open chain compounds. Till now you study three different types of compound: alkane, alkene, alkyne, based on the hybridization of carbon. So all these three comes under this if they are not forming any closed structure. So all the open structures they comes under this class. As soon as you have cycle formation, they goes to this class: cyclic or closed chain or ring compounds. Now wait, why this is happening? Now screen is visible. Now screen is visible. Okay. So now both is clear. Sound and screen. Yes. Okay. May I continue with my session or I need to repeat from starting? May I start from beginning or will continue? Okay. So, okay. So, cyclic or closed chain or ring compounds. So, in that I have two different types: homocyclic or carbocyclic compounds. Okay, Dia, you want me to repeat? Okay. So, organic compounds they are classified into two types: acyclic or open chain compounds, and cyclic or closed chain or ring compounds. So, acyclic or open chain compounds are the type of compounds where you have only straight chain of carbon present. There is no any other, no any close ring formation is there. So, only you have straight chain of carbon that may be branched, may not be branched. but that is not anyway, that is not forming any closed compound, cyclic compound. So that is acyclic or open chain compounds. When you are coming to cyclic or closed chain or ring compounds, in that case you have two different types: homocyclic or carbocyclic compounds and heterocyclic compounds. Now what is this? So homocyclic or carbocyclic compounds are the compounds where you have ring. Cyclic compounds, so ring is there, closed compounds are there, but in homocyclic, whole ring is made up of only carbon. Whole ring is made up of only carbon. As we discussed in last class, that each angle represent carbon atom. So in homocyclic compound, each angle is made up of carbon. See here in case of cyclohexane also, then even in cyclohexene also, whole structure is made up of carbon. Hydrogens are there, but whole ring is made up of carbon only. While here you see in this ring, this is again 5-member ring: 1, 2, 3, 4, and 5. Out of that, one of the position get occupied by oxygen, while rest 4 positions occupied by carbon. So here, apart from carbon, there is one another element present, and so this ring is known as heterocyclic ring. This ring is known as heterocyclic ring. So we have two different types of rings: homocyclic, or that is also known as carbocyclic because that is made up of carbon only, and heterocyclic where you have along with carbon some another element like oxygen, nitrogen, or sulfur may present. Again, when you are coming to carbocyclic rings, so carbocyclic rings are of two types: alicyclic and aromatic. Now, what is this aromatic compound? About this also you have to study in this chapter only at the end. So there we'll discuss about these aromatic compounds in detail. In that we have benzenoid compounds and non-benzenoid compounds. Here we have again two different types of compounds: benzenoid and non-benzenoid. Benzene ring is this one. See, this is your benzene ring where you have 6 carbon containing ring and 3 alternate double bonds present. This is benzene ring, while this is cyclohexene ring. Keep this in mind. If you have 6-membered ring with no any double bond, then this is cyclohexane. 1 double bond cyclohexene. And if you have 3 alternate double bonds present, then this is benzene ring. This is aromatic ring. Why this is known as aromatic ring? About this in detail we'll study towards the end of the chapter when we study this topic, aromatic compounds, in detail. And other class of compound, this also comes under aromatic compound, that is non-benzenoid. See, this is aromatic compound but not benzene ring containing compound. Here in both the cases you find benzene ring is a basic structure, well not in this case. So that way we have two different types: benzenoid and non-benzenoid. So this is what is about classification of organic compounds. As you learn more and more number of compounds, you get to know in detail about what actually compound these compounds is. Now we have to study about nomenclature of organic compounds. Now we are going to study IUPAC nomenclature. First of alkanes we will study. So first we'll study about straight chain hydrocarbon. Now what is hydrocarbon? So this you already studied in 10th standard, that compounds made up of only carbon and hydrogen, they are known as hydrocarbon. Compounds made up of only carbon and hydrogen, they are known as hydrocarbon. Under that you study three different types of compounds: alkane, alkene and alkyne. Alkane, alkene and alkyne. So if we go for IUPAC nomenclature, here at this stage in 11, at least you should know name of the hydrocarbon till 10 carbon atom. At least you should know name of the hydrocarbon till 10 carbon atom. See, one carbon containing hydrocarbon is known as methane. Now how to find out formula? So for one carbon you can easily write that carbon can form maximum 4 bonds. So as per this criteria, formula is CH4. But if you want to find out for any particular n number of carbon containing compound, the general formula which you have is, write down the general formula for alkane in comment box. Write down general formula for alkane in comment box. I didn't get any answer. Don't you know what is general formula for alkane? Write down. Yes. Yes. Yeah. Now, Dia, your answer is wrong. General formula for alkane is CnH2n plus 2. Correct. As per this, if you have to write formula for the carbon having 11 carbon atoms. Formula of alkane having 11 carbon atoms. Write down formula. Using this general formula, in comment box, write formula of alkane with 11 carbon atoms. C11H24. Correct. So answer is correct, C11H24. So as per that, you can write formula of alkane containing n number of carbon atom. Now at this level you should know at least name of the alkane till 10 carbon atoms. This table is showing you name, that is 1 carbon containing hydrocarbon, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane. 20 carbon containing icosane, 30 carbon triaconium, right? So this way you can write name of the hydrocarbon. Why we are studying this? This is very important for writing name of the hydrocarbon compound which we are going to study after this. Because your base carbon chain, that is hydrocarbon chain, so you should know name of at least that carbon chain. Okay. Now this is not always possible that if you have 5 or 6 carbon atoms, they are present in straight chain. So if they are present in the manner like branching, like this A, CH3, CH, CH3, CH2, CH3, or CH3, CH, CH2, CH3, CH2, CH, CH3, CH3. So this way they may present in the form of a branch. So in that case, if that is present as branch, suppose CH3 is present as branch. So CH4 is known as methane. But if CH3 is present as branch, then that is known as methyl. See here in this case, CH3 is attached as branch. So this is known as methyl. Here CH2, CH3 is attached as branch. This is known as ethyl because this is 2 carbon containing alkyl chain. Same way, C3H8 propyl. C3H8 is propane. If this is present as branch, then this is C3H7. This is propyl. C4H9 butyl. C10H21 decyl. So this way, if they are present as branch, we use term YL. We are removing ANE by YL. We are removing ANE by YL. Now, this is always not possible that all the three carbon atoms may present in straight chain only as a branch also. They may present like this. See, so then this is known as isopropyl. If three carbon atoms they are present as branch but not in a straight chain, but branching is from the middle carbon atom, then this is isopropyl. These five structures and their names are very important for you for nomenclature, and so keep this in mind. Hope you are sitting with one notebook and pen. Put heading IUPAC nomenclature of alkane. Put heading IUPAC nomenclature of alkane. Now, in that, take screenshot of the current screen. Take screenshot of the current screen. Okay. So, in a notebook, you have to write this table 12.2 and these five structures. These five structures. So if all the three carbon they are present in straight chain, that like CH3, CH2, CH2, and then you have this is attached to some chain, long chain. This is known as isopropyl. If arrangement is like this, then this is known as secondary butyl. See here, if all the four carbon they are present in straight chain, then this is normal butyl. So for to write that we use N dash small n dash butyl. Like here this is written normal propyl. We use normal butyl. But if this is present like CH3, CH2, CH and CH3. So you see here this carbon to which your long chain of alkyl is attached. That carbon is attached to another two alkyl chain and only one hydrogen. Two alkyl chain and only one hydrogen atom. So type of carbon is a secondary carbon. Type of carbon is a secondary carbon. While here you see this carbon is attached to two hydrogen atom and only one alkyl chain. Yes, of course, here branching is there, R is there. R is common in both these cases. This dash is attached to one long alkyl chain that may be made up of more than that, of course, made up of more than 4 carbon atoms, that may be made up of even 10, 20, 30 carbon atoms. So here the length of the chain is same. Now here if you say branching, in both the cases this branch comprises 4 carbon atoms. So this is butyl. In both the cases this is butyl. But see the difference. Here the carbon which is directly attached to alkyl chain, that is secondary carbon, because this is attached to two alkyl chain and only one hydrogen. So this is known as secondary butyl. Here this is also made up of 4 carbon atoms, but the carbon which is directly attached to alkyl chain is not a secondary carbon, that is primary carbon. But this all the 4 carbon atoms they are not attached in a straight chain, and so this is named as isobutyl. This is named as isobutyl. Same way, number of carbon atoms in this case, they are again 4. They are again 4. Now if you see the carbon which is directly attached to alkyl chains, that is, so if you see the carbon which is directly attached to the alkyl chains, that is tertiary carbon. How this is tertiary carbon? See, the carbon is attached to no any hydrogen. Here that is having alkyl chain attached. 1, 2 and 3 alkyl chains are attached. So all the four sides that is covered by alkyl chains. No any hydrogen is present. And so this is tertiary butyl group. Which butyl group? This is tertiary butyl group. Now find out number of carbon atoms in this branch. 1, 2, 3, 4 and 5. As per this is pentyl. Now again see the carbon which is directly attached to the alkyl chain, that is primary carbon. But that carbon is attached to quaternary carbon. See this carbon on all the four sides, this is surrounded by alkyl groups. And so this is known as neopentyl. Same way you can also draw secondary pentyl, isopentyl and tertiary pentyl. And this is neopentyl group. When you are writing secondary pentyl, you have to make sure that this carbon is a secondary carbon. When you are writing tertiary pentyl, you have to make sure this carbon is tertiary carbon. And when you write isopentyl, then you have to make sure that this is the carbon which is directly attached to alkyl chain, must be primary. So this is common branch groups have specific trivial names, and these are the trivial names, not IUPAC name. But when these are present as branch, we make use of these trivial names to show that this is present as branch. Now, nomenclature of branch chain alkanes. Let me start with this topic. Actually, this topic is very important for chemistry study, because wherever and whenever you study chemistry, you are going to deal with structures. And whenever we are going to deal with structures, at that time, you have to write a name of that compound. And to write name of that compound, we have some specific rules. If you know these rules, then easily you can write name of any particular compound. So whenever we start writing name of the compound, our first role is to find out longest carbon chain. Our first role is to find out longest carbon chain. As I said just now, there are many substituents present on the chain. But first we have to find out that which is the longest chain. Now here if you see this chain, now in this case I have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I go in straight, this is of 9 carbon atoms. But you don't have to find out longest carbon chain always in straight. That may be present like this also. But when we calculate number of carbon atoms this way, this is only 8, while in the straight chain this is 9. So the longest chain we'll consider is of 9 carbon atom. And this longest chain is known as parent chain or root chain. This longest chain is known as or considered as parent chain or root chain. Once you decide this, your next role is the carbon atoms of parent chains you have to number. Now how you will number? So for numbering, your next role is to decide substituents. So this is the chain which we have taken here. So the same chain they have copy here without hydrogen atoms. So this we have considered as a parent chain which is of 9 carbon atoms. Now if you see, we have two different substituents present. Here substituent of 1 carbon atom means this is methyl, and here I have substituent with 2 carbon atoms which is ethyl. So now substituent, we have decided that we have two substituents. So first you have to decide parent chain, and second you have to find out that which are the substituents present. After that, again there is one more thing, that you can number your chain even from left side, or even you may start from right side. It's not like you always you have to start from left side or right side. Then how to decide? So the numbering is done in such a way that the branch carbon atoms get the lowest possible number. The numbering is done in such a way that the branch carbon atoms get the lowest possible number. So let me once start with left side. So here methyl is getting 2 and ethyl is getting 6 number. Let me start from right side. Then in that case, ethyl is getting 4 and methyl is getting 8. So here numbering you are getting 2, 6, and in this case 4, 8. So as per the rule, you have to number in a way that they get the lowest possible number. In first case, you are getting numbering 2 and 6, while second 4 and 8. So which one is preferable? First one. So in this case, you have to number your carbon chain from left side. Once you give numbering, then next, so the names of the alkyl groups attached as a branch are then prefixed to the name of the parent alkene. Once you decide this much, now we are coming how to write a name. So first we have to write substituents present or branch present. First we have to write substituent present or a branch present, and then after that we'll write parent alkene. After that we'll write parent alkene. See, if this is the chain, this is the correct numbering. Then I have two branches present. One is methyl, another one is ethyl. My parent chain is made up of 9 carbon atoms. So as per that, I have methyl present on second position, ethyl present on sixth position, and 9 carbon containing chain, which is my parent chain, and that is nonene. So if I have to write a name of this compound, then I have to write 2 methyl, 6 ethyl, and nonene. Now, which one I have to write first, methyl or ethyl? So for that again we have one more rule, that whenever we have more than one substituent present, in that case, if different alkyl groups are present, they are listed in the alphabetical order. If different alkyl groups are present, they are listed in the alphabetical order. So we have to arrange them in alphabetical order. So as per alphabetical order, which comes first, methyl or ethyl? So as per alphabetical order, ethyl comes first, and so correct name of the compound is 6-ethyl 2-methyl nonene. This is correct name of the compound, 6-ethyl 2-methyl nonene. Next, if I have two substituents present, now you see both the substituents are same. So in this case, again I'll give numbering. Numbering I have to give in a way that branch carbon get lowest possible number. So whether I start from left side or right side, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. In both the cases, these are getting 2 and 4. Now, here both the functional groups are same. So instead of writing 2-methyl, what we write? 2,4-dimethyl. See, we use this di over here. We use this di over here to show that two methyl groups are present. And by putting comma between them, we have write number of both the carbon atoms where these methyl groups are attached. We have to write number of both the carbon atoms where these methyl groups are attached. So 2,4-dimethyl, as this chain is made up of, parent chain is made up of 5 carbon atoms. This is 2,4-dimethyl pentane. If I have 2, then I am using di. But if I have 3, I have to use tri. For 4, tetra. For 5, penta. For 6, hexa. So this way we make use of prefixes. This way we make use of prefixes if I have same substituent present 2 or more times. Now while writing the name of the substituent in alphabetical order, these prefixes are however not considered. What do we mean by this? So I have dimethyl and tripropyl. Now, if I want to arrange them as per alphabetical order, then I don't have to consider this di and a tri in alphabetical order. Only directly I have to consider methyl and ethyl. Again, you see the second example is given 1, 2, 3, 4, 5 carbon atom. Now, even I can give numbering from opposite side. So, in that case, this becomes carbon 2 and this becomes carbon 4. If this is so, now numbering comes 2, 4, 4. And as per this arrangement, because see, I'm first talking about the opposite one. If I'm giving numbering from this side 1, 2, 3, 4, 5, then numbering comes 2, 4, 4 trimethyl pentane. Another possibility is the one which is given 2, 2, 4 trimethyl pentane. Which one is more preferable? So in this case, we are getting 224. In the previous case, we were getting 244. So this is the one which is more preferable. This name is more preferable. Even teacher may ask you in problem. She may give both the names that 224 trimethyl pentane and 244 trimethyl pentane. Which name is more preferable? Then you have to give reason and right name. So this you can when you know every basic thing about this. Next is structure. So again this is made up of 7 carbon atoms. In this 7 carbon containing compound 1, 2, 3, 4 and 5. While 1, 2, 3, 4. So if I start from right side I'm getting 4 and 5. And if I start from left side I'm getting 3 and 4. So numbering from left hand side is more preferable. Now let me go for branching. So on third carbon 2 carbon containing compound, so this is ethyl. On fourth carbon 2 CH3CH means methyl. Again, while writing name, as I said, you don't have to consider this di ka D, and as per this I have to consider E and M. So E comes first, so 3 ethyl 4 dimethyl pentane. I hope now you understand at least basics about writing name of the structure. So let I give you few structures for which you write name in comment box. Write name of this compound in comment box. Write name of all these three compounds in comment box. Yes, so I'm getting answers. So 2-methyl 4-ethyl hexane. 1, 2, 3, 4, 5, 6. I need to number from this side. So this is correct. 2-methyl 4-ethyl. But which one I have to write first? Which one I have to write first as per alphabetical order? Ethyl comes first. So this is 4-ethyl 2-methyl hexane. Second structure 1, 2, 3, 4, 5, 6, 7. Hope you have not made any mistake in writing this. Again 4-ethyl 2-methyl heptane. Last structure I can start from any end. So of course I have to start from left side to get lowest number. Again I have two branch 2-ethyl 2-methyl butane. So these are very basic structures. I hope you understand. Uh, once you have not written numbering, your name is correct. 2-ethyl, no, 2-methyl. So ethyl again. While writing ethyl, you have to write numbering. You have to show numbering while writing name also. Another substituent also. Clear? So these are the names of compounds which as per your knowledge till now. Even more complex structures than this you have to study. If there is any query regarding what we discussed till now, just write in comment box. Yes, Vansh, what you want to ask? So let me move further. Yes, if you are not arranging these structures as per their alphabetical order, then this is wrong. Okay, let me move next. So fifth point, if you see, fifth point is if the two substituents are found in equivalent position. If I have both the substituents in equivalent position, like we have example CH3 CH2 CH, CH2 CH3, then CH2 CH2, CH CH3 CH2 CH3. See here, if I'm giving numbering from left hand side, then substituents they are getting 3 and 6. Even if I start from right hand side, then also substituents they will get 3 and 6 number. Count. So from which side we have to start? So for that also we have one rule that if two substituents are found in equivalent position, then in that case the lower number is to given the one being coming first in the alphabetical listing. The lower number is to given to the one coming first in the alphabetical listing. Next is sixth. So as per this rule, if we see, as per alphabetical order, ethyl comes first, and so 3 number will give to ethyl and 6 number to methyl. Next is branch alkyl groups. So the branch alkyl groups, how to name them? Now branch alkyl groups can be named by the following: the above mentioned procedure. However, the carbon atom of the branch that attaches to the root of alkane is numbered 1. Wait for a second. Be online. On. Mhm. Okay, so let me continue. So we are here at the sixth rule. So the branch alkyl groups can be named by the following: the above mentioned procedure. The carbon atom of the branch that attaches to the root alkane is numbered 1. Suppose this much long substitution is present in your main chain. This is substitution given to you. Huh? So in that case, how to write name of this substituent? So to write name of this substituent, the method we use, see this is the first carbon which is directly attached to the alkyl chain. This is the first carbon which is directly attached to the alkyl chain. Now to that we have to give one number, and then you give numbering as you are giving it to as you are writing parent chain, then substituents. So this is my parent chain which is of 4 carbon. But as still this is substituent, we use term butyl. 4 carbon containing butyl. To that I have two substituent presents, 1 and 2. Now again I'll write 1,3 dimethyl. Here I'll write 1,3 dimethyl butyl. So this is whole one substituent, this is one whole branch. So if these kind of big branches are present, then we have to write name this way. So the name of such branch chain alkyl groups is placed in parenthesis while naming the compound. What is parenthesis? What is parenthesis? So parenthesis is, here you can see they have shown bracket. So this bracket in the language of chemistry is known as parenthesis. Parenthesis while writing name of the compound. While writing the trivial names of the substituents in alphabetical order, the prefixes iso and neo are considered to be part of the fundamental name of alkyl groups. If you are writing IUPAC nomenclature, if you have to arrange them, suppose you have isobutyl and tertiary pentyl, if you have to arrange them in alphabetical order, then iso and neo you have to consider in fundamental name of the alkyl group. But at the same time, prefixes secondary and tertiary are not considered to be part of the fundamental name. Means SEC and TERT. This I don't have to consider in parent chain. In alphabetical order, I don't have to consider them. So use of iso and related common prefixes for naming alkyl groups is also allowed by the IUPAC nomenclature as long as these are not further substituted. In multi-substituted compound, see rules. See, this is the one compound given to you. This is a complex compound. Let me go one by one for this. What is our first rule? To decide longest hydrocarbon chain. Let us start counting number of carbon atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I'll take this, then also this is 10 because this is CH, CH2, CH3, CH, CH2, CH3. So by the ways this is 10. Even 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This way also this is coming 10. Now I have two straight chains, two long chains which is of 10 carbon atoms. So which one I have to consider in this case? So the rule says that if there happens to be two chains of equal size, then that chain is to be selected which contains more number of side chains. If there happens to be two chains of equal size, then that chain is to be selected which contains more number of side chains. What we mean by this? So if I take this as a parent chain, this straight chain as a parent chain, I have two substituents present. One is this and another one is this. Right? If I take this straight chain as parent chain, then one this substituent and another one is this substituent. But instead if I take this chain as a 10 carbon parent chain, then number of substituents present you count 1, 2, and this whole group is 3. So this way I have 3 substituents present. So in this case, as per the rule given, which one is more preferable? This chain is more preferable. Now numbering. From where to start numbering? So the numbering I have to start in a manner that branching gets lowest number. So of course I have to start from here because here at this end I have two substituents present. So I'll start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon parent chain, so decan is fixed. 10 carbon parent chain, so decan is fixed. Now next thing is substituents. On third carbon, two methyl groups are present. On fifth carbon, one complex group is present. About this earlier only we discussed that the carbon which is directly attached to the alkyl chain or main parent chain, to that we have to write 1, 2, 3, 4. I can also go this way, but both the ways this is same. So I have written 1, 2, 3, 4. Again on second chain, ethyl branch is present. As mentioned earlier, this is 2-ethyl butyl. This is 2-ethyl butyl. This whole is branch. This whole is branch 2-ethyl butyl. So that we have to write in parenthesis. 2-ethyl butyl in parenthesis means in bracket. This is attached to parent chain by which carbon? Fifth carbon. So 5 dash 2-ethyl butyl dash 3,3 dimethyl, and as per rule also ethyl comes first and then methyl. As we are we are not considering in the fundamental chain, so methyl comes afterwards. So 5 dash 2 dash ethyl butyl dash 3 comma 3 dash dimethyl decane. See here, if you see clearly, this is given that whenever you have substituent and number, then you have to put dash, but between two number you have to put comma, and not this one. This is incorrect name. You can't write this first, right? So 1, 2, 3, 4, 5, 6. The sixth carbon this is coming. Oh, this is what, 3 ethyl. Okay. Coming to next compound, 1, 2, 3, 4, 5, 6, 7, 8. Not possible. Of course, this is also 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbon. So this is the only longest chain. See here, CH3 twice written. This means you should know CH that is attached to two CH3 groups. Okay. This CH3 twice. I'll show you. See, this is written as CH3 twice. Got it? This is complete formula, and the one which is written is the condensed formula, CH3 twice. So to this they have written over here in this manner, CH3 twice. Okay. Another branch present which is a 4 carbon atom but not a normal one. See, this carbon which is directly attached to alkyl chain is a secondary carbon, and this is a 4 carbon atom, so this is secondary butyl. This is isopropyl. Now, as just we read that secondary and tertiary you don't have to take in fundamental chain, and iso and neo you have to take. So here for secondary butyl we have to consider B, and here for isopropyl we have to consider I in alphabetical order. So as per alphabetical order, B comes first because this we are not considering. So this becomes 5 secondary butyl, 4 isopropyl decane. Next is CH3, CH2, 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 CH, CH2, 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 CH3, and this whole branch. Again, branch is of 5 carbon atoms. So to this you directly can write neopentyl. This is neopentyl. 1, 2, 3, 4, 5 carbon atom, and the carbon which is directly attached to chain is primary, but that is attached to quaternary carbon. This arrangement is known as neopentyl. So if you write 5 neopentyl nonane, but neopentyl you have to write this way, 5 dash neopentyl and then nonane. This is also correct. Or else if you write this way, that 2,2 dimethyl propyl nonane, this is also correct. About this you'll get more and clear idea when you practice this. I'll send you one worksheet for this today in WhatsApp group. Using that worksheet you have to solve number of compounds More and more compounds if you solve, then only you get idea about this. Cyclic compounds. Saturated monocyclic compounds is named by prefixing cyclo to the corresponding straight chain alkane. If side chains are present, then the rules given above are applied. Like this is of 5 carbon, no any double bond present, nothing. So this is pentane. But as this is cyclic, we use cyclopentane. Same way cyclopropane, cyclobutane, cyclohexane, all this is possible. See again, this is 6 carbon containing cyclic chain, no any double bond present, so this is cyclohexane. But here I have two different chains arranged attached to it, so I have to give numbering in a way that they will get lowest number. Methyl and propyl, which comes first as per alphabetical order, so M comes first, and as per this will get lowest number. So 1 2 3, 1 methyl, 3 propyl, cyclohexane. Here I have three substituents present. Of course, as to this carbon, two substituents are present. This will get lowest number, and this will get third number. So 1 dimethyl, 3 ethyl. But if we have to write as per alphabetical order, this comes first: 3 ethyl, 1 dimethyl, cyclohexane. Here problem 12.7, structures and IUPAC names of some hydrocarbons are given below. Explain why the names given in the parentheses are incorrect. So CH3, CH, CH2, CH2, CH, whole chain is given. Now you have to explain why the names given in parentheses are incorrect. So this compound is named as 2,5,6 trimethyl octane. This is correct name of this compound, but this can't be named as 3,4,7 trimethyl octane. So you have to write reason that why this name is incorrect. So as per rule, you have to give lowest number to the substituents, and so lowest locant number is 2,5,6, while the name given in parenthesis as 3,4,7. So this is your reason that lowest locant 2,5,6 is lower than that of 3,5,7. That's it. Second, 3-ethyl 5-methyl heptane. This is correct name. 1, 2, 3. If you start from this side, 4 and 5. If I start from this side, 1, 2, 3, 4 and 5. So from both the sides, we are getting 3 and 5. In this case, what is our rule? What our rule says? The rule says that the lowest number goes to the substituent which comes first as per alphabetical order, and ethyl comes first. So here in this case we have to start numbering from left side. So 3 ethyl 5 methyl heptane is correct. So you have to write that substituents are in equivalent position. Lower number is given to the one that comes first in the name according to alphabetical order. So here we'll able to complete our nomenclature of basic alkane chains without any functional group. In the next class, we'll study about different functional groups and how to write name of those compounds if functional groups are present. Actually, these lectures and all this chapter is very important for your organic study till you continue with chemistry subject. So here I'm ending my today's session. This is the table given for functional groups. Out of these, alkane, alkene, alkyne, arenes, these four you know very well. Even you know halides, alcohols, aldehydes, and ketones. These four functional groups are given to you in 10th standard textbook. But again, we'll study, revise this, quickly go through this, and in detail, we'll study all these functional groups and how to write name of the compound if these functional groups are attached to your parent carbon chain. About that also we'll study in detail. Actually, this whole structure is very important for chemistry study. So concentrate this, don't take this lightly. Put your sincere efforts for whatever homework I'm giving. I'll share homework with you in WhatsApp group. Recently, I'm showing exercise also to you. This is the reason I'm scrolling pages. So this is your exercise. Out of that, you can do 12.1, 12.2, 12.3. Even you can solve, no, 12.3 only you will know this. Then this you can write, this you can write. So all those which you can able to solve, you solve those compounds. Here in this A and B also you can solve. And rest of the exercise I'll send you in group. Do that. Hope today's class is very clear to you all. Here I'm ending my session.